Hey, hello, welcome to the show. It's me, JP, and it is time for JP's product pick of the week. Thank you so much for joining. Thanks for stopping by. Thanks for heading on over to our chats. We have a YouTube chat up, so if you're watching on YouTube, you can head over there. I'll say hi, I promise. And if you are somewhere else that doesn't seem to have a chat, then check out our Discord. It's right here. This is the Discord at adafruit.it/Discord. That's our URL shortener. You can find it there on our website, and you will find a link that goes and takes you to our server on Discord, and then you just want to look for that right there, which is the live broadcast chat channel. And hello to Blitz City DIY. Hey Liz, thanks for stopping by. And Paul Cutler, hello. Looks like Thin Man is typing there. Hi. Thanks for stopping by, and let me get that out of the way there. Let's talk about what's going on. I've got a new product pick. If you want to go check it out, you can go, oh, that's not the button I wanted. You can go there. Go over to product 6432. And this show right here that you're watching is live streamed from inside the product page, so you can go there and you won't miss a beat. You can throw it in your cart. You can buy it for 50% off, which is the price break that we've got going for this product today. And there are no coupon codes or anything like that. The price will just go up after the show is over. So if you want it, get it. And this one, I have no new video for this one from Lemoore. It's a new enough one that hasn't been made yet. So this is the first video about it. So without further ado, let me show you this right here is the product pick of the week this week. It is the ADS122C04 24-bit ADC. This is a STEMMA QT format board for I2C information heading over to your microcontroller, or you can use the pins that are broken out for that. And across the top, you can see there we have 4 analog inputs, so you can use this for individual analog input. You can also use this in differential pairs for things like strain gauges. So let's take a look right here at the product page. You can see we have it for half off. It is $9.98. And it is, let me grab my notes on it. Where'd you go, notes? So there we go. So this is great for high precision stuff. You don't probably need anything this high precision for just things like potentiometers, but for things that have very small differentials in voltage, things like strain gauges used for making scales, pressure sensors, flow sensors, patient monitoring devices. This is used in some medical applications, body temperature, blood pressure. There are all these devices that have very low voltage changes in the analog measurement, and you can use those either for single-ended inputs or the differential pairs. So, for example, let me show you what I'm talking about here in sensor terms. Let me bring this up here. We probably even have some linked down below. Let's see. No, we don't. Okay, I'll just type in here in the Adafruit search strain gauge. So these strain gauge load cells, you can't really just read these with a normal analog in. You're not going to get the info you need. These have 4 wires, so we give it essentially a reference for ground and voltage, and then we can read the differential pair to determine the deflection of the strain gauge. In fact, the one I'm going to demonstrate is this one right here, the 1 kilogram. This is perfect for things like measuring your coffee grounds, that kind of stuff, low weight stuff. But measuring this accurately is really difficult unless you have a gizmo like what we've got here today, which is this 24-bit ADC 4-channel. So let's, in fact, looking at the product page here, you can scroll down and you'll see we have a link to this Learn Guide. So if I head over to the Learn Guide here, let's take a look at the pinouts on this. So we have the voltage in, and this will allow anything from 2.5 to 5 volts to power the board. And you can use this with older Arduino boards that are 5 volt or more modern 3.3 volt boards, such as Cutie Pies and Feathers, things like that. There is And by the way, that voltage in, I believe that's the same one that you can get over the Stemma QT cable. So just to power the board, we're going to use the 3.3 volts typically coming over Stemma QT cable, and that also gives us ground, data, clock. But then we also have the reference plus pin. So this is not connected to the, it is not connected to the ADC, which will use the internal 2.048 reference voltage. There's the ground, and then there's the reference minus. And I'll show you how that's set up in a second. Then we got the logic, I2C logic pins for sending that data and commands back and forth. And then there are these 4 ADC inputs. So A0, A1, A2, A3. They can get up to 2,000 samples per second. That's what this 2K SPS that you see mentioned on the board page is. And then we also have 2 address jumpers on the back. So you can get 4 of these on a single I2C bus if you have some need for a lot of ADC sensing on one board. This will work well for you. And then the other pins on here, there's a data ready pin and a reset pin that you can use. And then there's also a power LED on the board and a jumper to cut that if you don't want to see the power LED. We have a couple of pages here on how to use this in CircuitPython and Arduino. And this shows a simple example of just reading a potentiometer. And this will also work with single board computers using Blinka. I've also added, when I was setting this up yesterday actually, I added the code that I've got in the demo to this little example code section down here for strain gauge load cell usage. You can see in the main Learn guide there, you can read all 4 pins and just get a voltage off of that. And I've set an example up here that uses one of our typical load cells and a feather board. So if you continue on the journey of the Learn guide here, you'll see we've got a link to the downloads page. And there you'll find CAD files, fritzing diagram, as well as the data sheet for the chip itself from TI. So you can see here some of the features they mentioned. Current consumption as low as 315 microamps. Wide supply range, 2.3 to 5.5. You can program your gain, and this is important for getting the particular sensor you're using to give you results that work well, anywhere from 1 to 128x. And programmable data rates, how fast you want to read this sensor. You get up to 20 bits of effective resolution. I don't know where the lost 4 bits go. And there are simultaneous 50 and 60 hertz rejection at the 20 SPS with single cycle settling digital filter, so it helps smooth out your results that you're getting off the sensor. Gives you more info about temperatures and percentage of accuracy. And here they mention applications, field transmitters for temperature, pressure, strain, and flow, PLCs and DCS analog input modules, temperature controllers, heat meters, patient monitoring systems, blood temperature and body temperature and blood pressure, not blood temperature, I hope not. And more, and then implementation notes as well. So let's get to a demo here. Just going to double check my chats to make sure there's no questions or concerns before we move on. So here you can see I've got a little demo I put together. And so right here we have the ADS122C04. I have it plugged into a feather board over I2C just to power and data between the sensor and the feather board. This is a feather with a TFT on it, so we get a nice little display there. And then you can see I'm running my 3 volts and my ground from the feather as the plus and minus reference for the load cell that I've got here. I have the load cell's red and black wires plugged into those reference voltages, and then I have the green wire and the white wire acting as the differential pair for strain gauge sensing on this. So right now I'm going to press the D0 button on the feather just to tare it to make sure that I've got 0 meaning 0. And then let's take a look at, I'm just going to weigh a stack of quarters here. So 5 quarters I found out is about an ounce. So if I put that on there, I'm reading 28.7 grams or 1.01 ounces, which it's not going to be exact just because of dirt and wear and this and that, but pretty close to exactly an ounce on that. And the neat thing about the tare feature is that if I'm going to measure this big ball bearing, it's actually a pinball, and I warned you, my entire personality is pinball machine now. if I put this ball on the scale there, it's just going to roll off. So I've got a little holder here that I 3D printed, and that's weighing in at 4.4 grams. So I'm going to press that tare button. It's now going to essentially subtract that from the weight. And pinball is supposed to be 80 to 81, I think, something like that, grams. And I've got another one here that's a little bit slightly different. That one's 81.0 grams. So that's a really typical use for this type of sensor, is to set up a very accurate scale. And if you want to see a little bit about the code that I've got running on here, let me bring up my coding window. And you can see the key things are going to be to import from the ADS122C04 library that we have for CircuitPython, the ADS122C04, gain 64 I'm using, MUX, which allows me to use the first two, the A0 and the A1, as a differential pair, and the external voltage reference. So I'm bringing all of those in. And then I've got some variables here for the gain, the scale factor, which I used a little calibration code to determine the precise scale factor so that I could get accurate measurements for the grams, ounces, and pounds on here. Number of samples, so I'm sampling it 8 times for a typical measurement, which means it's fast enough to do something like an espresso pour. I've made, with the help of C. Grover, actually, I've made an espresso scale in the past, and I have a Learn guide on that using a different load cell sensor. But you don't want to spend too much time sampling if you're trying to precisely figure out the weight of something and stop it before it goes over. So 8 samples seems to be pretty quick for this. As you can see here, it gets a pretty quick measure on that. I am taking 32 samples during the tare process, and you could increase that if you wanted to get a even more accurate tare. And let's see, anything else in here that really matters is just how you read the thing. So we set up the ADC MUX as this MUX analog in 0 and analog in 1. And then when I actually want to read it down here in both these functions here, this read raw function, it's just going to ask for the read data, ADC read data. Everything else has already been configured, so it just gets that 24-bit value that's come off of the deflection of the sensor. And then in my main loop, I'm calling those functions and then doing some conversion to display those as the different measurements. But so this is, for this scale, this is good for smaller objects up to a kilogram. I've got something I was weighing before on a highly accurate other scale I have, and this one, and comparing. This happens to be a big latte glass, coffee latte glass, with my pinball in there and the holder. So I was just comparing those to a known good scale. I don't have any scientific weight. I should get some very accurate weights to measure these against. That would be neat. So that is the basic usage of this, and there's examples, like I said, in the Learn guide for Arduino as well as CircuitPython. And let's see, what else? Let me show a couple of nice big photos there, front and back. So you can see there are the jumpers on the bottom for changing addresses to get 104 addresses on a single I2C bus. As well as the jumper there for the LED. It's not labeled, but that little jumper that you can cut there will turn off the LED on the front for power. And let's see, I think that is it. So let me know in the chat if you have any questions. I'll throw the URL right there again. If you want to go and pick some up, you can use that QR code, you can use that URL, go pick them up, throw them in your cart. They will be priced to sell at this discount until the end of the show, and then they'll go back up. And tell me what you're using yours for. We sold a bunch already, over 20 of them. So let us know. What are your highly accurate analog sensing needs? I'm always curious to know. Or you don't have to tell me if it's secret. I'll respect that too. Okay, that is going to do it for product pick of the week. That right there, that's the product pick of the week. This week, it is the ADS122C04 24-bit ADC 4-channel 2K SPS STEMMA QT and Quick. Whew! For Adafruit Industries, I'm John Park. This has been JP's Product Pick of the Week, and I will see you soon. Bye-bye.